These are the notes for 7.1 on 0 and negative exponents. You should have in junior high school already done some with exponents, so we go a little bit faster through this chapter because it should be a review for you. But just a quick reminder of what an exponent means. Remember, that doesn't mean 8 times 2, it means 8 times itself 2 times. So make sure you don't make the common mistake of saying it's 16, but we should know that. Next up, be very careful with negatives, because if you write this as negative 3 squared, really what that means, if you write it like this, is that it's negative 1 times 3 squared, which is actually negative 9. And that's not what this problem's asking you to do. It's asking you to square x, and x is negative 3. So we have to make sure we consider it in parentheses, especially if you use your calculator to do it. So that means negative 3 times negative 3, and a negative times a negative gives us a positive. So be careful when you're working with negatives. Now in this one, we've got a little bit different thing going on here because we have the negative out front. Really what that means is take the opposite of what you get when you raise x to the 4th. Well, x is negative 2. I'm going to raise it to the 4th. And then I have this negative out front. And you might be thinking, well, my teacher has always said that a negative times a negative gives me a positive. And you might think that that means the answer is positive. However, we've got rules of order that have to happen first. And you also might remember somebody in junior high or elementary school telling you the order of exponents. Please excuse my dear Aunt Sally, and we need to make sure we do things in that order. Math does not get done like English does, from left to right. Math gets done by the strongest operations first, and we've got parentheses and exponents that beat out multiplication, division, addition, and subtraction. And again, this is really negative 1 times negative 2 to the 4th. So what I need to do is raise negative 2 to the 4th first, which would be a negative 2 times a negative 2 times a negative 2 times a negative 2. That is no kind of an 8. Every 2 negatives makes a positive. So because I have 4 of them, I'm going to end up with positive, and we've got 2 times 2 times 2 times 2, which is 16. However, we had this negative sign out front, so we really have negative 16. On this one here, there was not a negative out front, there was a negative being squared. So just the moral of that story is be very, very, very careful with your negative exponents. I'm going to fix the screen down here for a second. Not negative exponents, your negative signs in both the bases and out front. I'm going to see if I can clean up my area here. All right, so in the next part here, we are going to discuss what happens with 0 powers and negative exponents. Now, if I were to ask you what's 6 to the 0, the most common answer I get from people is 0. The second most common answer I get is 6. So we're going to discuss what it actually is here by completing this chart, doing a little discovery. So we're going to start with where you're most comfortable, which is right here at 2 to the 1st power, which means 2 once, which is 2. 2 squared is 2 times 2. 2 to the 3rd is, again, doubled. So we're just doubling or multiplying by 2 as we move in this direction. Note every time when we're moving in that direction, we are multiplying by another 2. Now, consequently, if I use that analysis, then if I move in this direction, the opposite of multiplication is division. So you'll notice 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and 2 divided by 2 is 1. So you'll notice I did not get 2, I did not get 0, I got a 1. And I could have had that base be anything. Watch, we're going to go to base 10 here just so you can see it. Again, we'll start where you're most comfortable, which is right here at 10 to the 1st. 10 to the 2nd is 10 times 10. And I'm just multiplying by 10 as I move and add another positive exponent. So when I'm going this way, again, I'm multiplying by 10. When I go this way, I'm dividing by 10. Divide by 10, divide by 10, divide by 10, divide by 10, and I get a 1. And my base could have been any number. I chose 2 in this scenario and 10 in this scenario, but it could have been anything. Now, I'm going to continue that process as I move to the right. I'm dividing by 2, dividing by 2, dividing by 2, dividing by 2, and now I have to take 1 and divide it by 2. And then I have to take a half and divide it by 2, which is a fourth. And then I have to take a fourth and divide it by 2, which gives me an 8. And then a 1/16. And you'll notice that what I'm getting here is the reciprocal or the flip of what I have on the positive. 2 to the second is 4. This is 1 over 2 to the second. 2 to the third is 8. This is 1 over 2 to the third. 2 to the fourth is 16. 2 to the negative fourth is 1 over 16. So when I have 2 to the negative n, over here, oops, sorry, my screen's got a little problem here. When I have 2 to the negative n, really what I end up with is dividing by 2 n times instead of multiplying. I'm going to fix my screen for a minute, so you can just hang out there for a moment. I'm going to enlarge my viewing window here if I can. It looks like that's as big as I can make it. I don't know why. Oh well, we'll work with it. Alright, so next up on the bottom, I'll continue that thought with the 10 also. This means divide by 10 one time, so 1 divided by 10. This means divide by 10 twice, or 1 over 10 times 10, or 1 over 100. It's all the same thing. This is 1 over 10 times 10 times 10, or 1 over 10 to the third. 1 over 1,000. Notice it's the reciprocal. 1 over. And then this is 1 over 10 to the fourth. Notice what's really important here. I am not getting negative numbers. Kids in math like to do what looks good. So they like to say 6 to the negative 2. They like to tell me that's negative 12 or negative 36. Or they see this one negative and they think the answer is negative. But it's a negative exponent. And what that means is I need to do 1 over 6 to the second, or divide by 6 twice. It's actually 1/36. It goes kind of against what your gut would tell you just by looking at the numbers. So it says, what do you think any non-zero base? What does that mean, non-zero base? Well, in these, remember, this is a base of 10, 2, this is a base of 10. What that means is any non-zero base to the 0 power. What do I think that would be? Well, I happen to use base 2 and base 10, but I could have done anything. I think anything to the 0 power is going to be 1. Because what's going to happen is we're always going to be dividing the base by itself. So we'll get a 1. What is the relationship that you see between the positive powers and the negative powers? Well, what I'm noticing is that when I take anything and raise it to a negative power, I don't get a negative answer. This negative sign actually means division. So it means I'm going to divide by a n times. I get the reciprocal, or the flip, of the positive power. And I'm going to skip that question. Let's go to the next one. So now we have our 2 key ideas here, and then we'll just go through and work through some examples. So what we just said is that anything to the 0 power is 1, any non-zero base. And we said that negative exponents mean division. They don't mean negative answers. They get things really, really, really small, but they don't go negative. So I get 1 over a to the nth. And you might want to put a little example of that over here, that if I say what's 4 to the negative third, I do 1 over 4 cubed. All right, so let's go take a look at some evens from the book, because you will be doing the odds. Anything to the 0 power is 1. So this is 1. I could put a ton of stuff in the parentheses, and if I raise it to the 0 power, my answer is 1, as long as everything's in the parentheses like that. However, I caution you, had it been written like this, then the answer is -1, because that negative is out front. It means -1 times. And so you got to be really, really careful with where that negative is. Let's go take a look at number 12. I have this negative. That's really -1 times 5 to the negative second. So be very careful. I am only taking the 5 and raising it to the negative second. And powers get done first. That's not 10, it's not negative 10, it's not negative 25. It's 1 over 5 to the second. So be very careful with that. And then I still have the negative 1 out front here. So I've got negative 1 over 25. A very common wrong answer to that is positive 10 because you do what you think looks good. So in number 16, let's take a look at this. Again, another negative that's not in the parentheses. So be careful. I'm going to rewrite that as negative 1 times 12 to the negative 1. I'm going to use my rules of order and I'm going to do the exponent first. These negative exponents mean go down, divide by that. So I've got negative 1 right here times 1 over 12, which gives me negative 1/12. So we've got to be really, really careful with those. This is not negative 58. This means divide by 58 once. So, and you don't need to put the 1 on the exponent there because it's implied, but if it's there, it certainly isn't wrong. So let's go take a look at number 20. A negative exponent means I'm going to be dividing. My base is the entire negative 5. So in this one, I am going to take the entire negative 5 and divide by it 3 times. What that gives me is no kind of a 15, negative 5 times negative 5 times negative 5. You might need to write that out or take out a calculator or what have you. But on this one, we have 3 negatives will balance out to be a negative. 5 times 5 is 25. Times another 5 is 125. So we would write it like this. Now, 22 is interesting because what's happening when we have our negative exponents is I said that means division. And that means that when you have, say, x to the negative 2, it means you divide by x twice. Notice what happens is that negative actually sent it to the bottom. And what I like to think about it is like when my kids are annoying me if I'm upstairs. If they're being annoying and negative, I say, go downstairs. If I'm with them downstairs and they're being annoying and negative, I say, go upstairs to be more positive. So really what those negative exponents do is they flip it over and they send it to the other level. Now, if you're already on the top level, like this, you go down to be more positive. But if you're down, you go up to be more positive. And so it has a reciprocal effect, is what the negative exponent does. Now let's move on and do a couple harder ones. So, oh, there's that same one again. So this is in the bottom. It's going to go up to be more positive, and 1 would be on the bottom, and that doesn't do anything. So, well, actually 1 would stay up on top. It's going to look like that. Let's go look at number 24. What do we get here? This means it's being too negative on the bottom. I'm going to send it up to the top to be more positive. Now, 1 times c to the positive 1. I mean, that's like you telling me if I say how old you are you, and you say, well, I'm 1 times 15 to the first. Well, that's kind of ridiculous. You're just 15. So make sure those ones don't really matter here. Now let's look at number 26, piece by piece. This is k to the negative 4th. What's that going to do? Means divide by k 4 times, it's going to send it to the basement. J to the 0 is a positive 1, so I'm going to have a positive 1 on the top. Number 28, piece by piece, the 7's going to stay put. It's a positive exponent. The A is going to stay put, positive exponent. The B is going to get sent down to be more positive. The 3 is going to stay put, and the W is going to stay put. Now that's kind of messy, so I'm going to write it a little better. Notice all the positive exponents stay on their levels. If you're being positive, I'm not going to send you to the other level. You're not bugging me, all right? But this negative exponent right here on the B means you're going to have to go down to be more positive. All right, let's go look at number 30. Number 30, C is going to move down to be more positive. It means divide by C 5 times. D to the 7th is just fine by me. It stays put. Number 32, the 7 stays put. The S stays put. The 5 stays put. Why? Because they all have positive exponents. Notice, had this had been a negative 7, it stays put also because it still has a positive exponent. So be careful with that. My T is negative on the bottom. What that means is it's going to go to the top. It has that reciprocal effect. I think it got cut off by the screen, So we'll write that a little better. We're going to have the negative 7s, we're going to have a 5 on the bottom, and a t cubed on the top. All right, moving right along here, we're on number 34. All right, piece by piece. What am I going to do with that 2? I like to just put a fraction bar down